And let me take a whiteboard. Okay. Let us take a whiteboard. So first we know the divisibility. So far you know the divisibility by what are all the numbers, you know. Divisibility by 2 is very easy, right? All even numbers, right? 3, it is very easy. Well, how do you do? Sum of the digits should be divisible by 3, right? So I will just say sum of the digits by 3. I will remove this by 3, right? This is what you know, right? How do you find out whether any number is divisible by 3? Just add the sum of the digits. Is it divisible by 3? Divisible by 4. So say last 2 digits by 4. If they are divisible by 4, then the entire number is divisible by 4. Why? That is because last 2 digits are like the tens place and the units place. Before that is the hundreds place, and 100 or any times 100 is always divisible by 4, right? Because 100 is 25 into 4. So any number which is into 100 will always be divisible by 4. Only thing is that something into 10 may or may not be. For example, 3 into 10, 30 is not divisible by 4. Okay, so 10 into something plus units place, that you have to add and then you have to check. Then only divisibility by 5. Last digit has to be is 0 or
0,
right? Divisibility by 6, it is
2. It should be
by 2
by
and then by 3, right? And also by 3, 2 and also by 3. So it has to be even number first, and then the sum of the digits have to be divisible by 3. If that is the case, then the entire number will be divisible by 6, right? Because 2, it is divisible by 2 also and 3 also. Now coming to 7, do you know what is the divisibility by 7?
No, sir.
Huh?
No.
You can't, right? So there is a solution for any number to divisible by 7. Okay, there is a formula. So I'll tell you what is the formula. Okay, what is the first you take the alternating sum of groups of 3 digits. What do I mean? Give some large number. Madhura, give me some large number.
64,387.
64,387. Okay, so you starting from the leftmost, you start forming them into 3-digit groups. So here it is 64 and 387. Now you say 387 minus 64. Okay, so if there were, I will take the example next. What if it? Now you have to find out this number. What is that? Is equal to 323, right? Now, correct, na? 323. Now,
Yeah.
if this number is divisible by 7, okay, then the entire number should be divisible by 7. I think this is what it is. Let me just, I have to recall, but I can refer also, but just check. Now, how to find out whether a 3-digit number is divisible by 7? Either you can do method, you can just do it, okay, and find out what to call. So, for example, we'll just check this. What it will be. So 7 into 4 is 28. So balance is 4, 43. 7 into 6 is 42. So 1 is remaining. So it is not divisible. So I think 64,387 is not divisible by 7. We'll just check it on the calculator. 64,387 divided by 7 is equal to, yeah, there is 1 extra is remaining. But now because 323, we are getting 43 at the end, and that is not divisible. But so just let us check out 386. Now that is 386 minus 64, and that will be 322. Now 322 is divisible by 7 because 7 into 4 is 28. 32 minus 28 is 42. 7 into 6 is 42. Exactly 0. Right? So if 322 is divisible, I mean this 3-digit number is divisible by 7, then the entire number is also divisible by 7. Okay. So this is the logic. So let us take an even larger example. Okay.
It was 864, 355.
864, 355, huh? This number?
Yeah.
Okay. So again, let us form the sum, alternating sum. 355 minus 864. Okay. So 355 minus 860. It will be some negative number, but see, it doesn't matter. Negative numbers are also divisible. So just as 0, 8 is divisible, similarly, minus 8 is also divisible by 8. Similarly, 7 is divisible by 7. Minus 7 is also divisible by 7. So it doesn't matter. The negative sign will not matter. Okay. So finally, basically what matters is the, so 355 minus 864, we can simply drop the negative sign and then just check. Okay. So 5 minus 4 is 1. 5 minus 6, it does not happen. So 15 minus 6 is 9. And 2 minus 8 is 6. So minus 691. So we have to just check whether 691 is divisible, right? 691. So 691. So 7 into 9 is 63. Then what remains is 6. 6 and 1 is 61, right? So again, 61 is not divisible. So I don't think 864, 355 is divisible. Let me check. 864, 355 divided by 7. Yep, it is not divisible because it gets a remainder of 2, right? Remainder of 2 is what exactly you get when 691 you divide by 7, right? How? 7 into 6, 7 into 9, 63, 61 remains. And then, yeah, actually it is not. Remainder can be off, but whatever. You know that there is some remainder, so it is not divisible, right? You got it, Madhura? There is an even shorter thing to find out whether any 3-digit number is any 3-digit number.
Sir, this is not how you subtract, right?
Sorry?
This is not how you subtract, right? A larger number.
Yeah.
Like here, 355 minus 864, it should be 864 minus 355, and then you add a negative sign to it.
Yeah, but same thing you will get, na? Okay. Sorry, I did some basic mistake. Huh? Yeah, wait. I said no, but you can divide it. So what you will get is the other number. Yeah. Sorry, I did some.
Yeah.
So 6. So what will be that? 14 minus 5 will be 9. Sorry, 14 minus. Yeah, this is what happens when you are too much into the thing, right?
Yeah.
Full thing. Yeah, 14 minus 5 is 9. Then what do you get? 14 minus 5 is 9. Then 5 minus 5 is 0. 0. 5. So minus, and there is a minus, but minus we can ignore. So 509. So 509 divided by 7. 7 into 7 is 49, and you get 1. 19. So 7 into 2 is 14. So there is a 5 remainder. Actually, that is what you remain. 864, 355 also. 5 is the remainder when you divide by 7. And that's what you get it when you try to divide by this one. Okay. So, and it doesn't matter. Suppose even if we are talking about, I will take one now. I will just tell you that 2 and this one, in fact, 5, 864, 355. This should be divisible by 7, I think. And how? Let us see. What is the alternating sum? So we have to take 355 minus 864 and plus, actually, I think it is 2. It will not be divisible, but let us just take it. I think I will just take it. Sorry.
One number plus, then the other is subtracted, then the one more is added that way.
Yeah, correct. Exactly. So 355 minus 864, and again that whatever is the number 5. Actually, it is 005. You can consider it as, but that is 5, right? So what does this number become? So earlier it was minus 504. Now it will become minus 509. Actually, but minus 509 plus 5 it is, correct? So it is minus 504. So minus 504 is the number, right? And again, you can drop the minus sign, and now it is 7 into 7 is 49, and 1 and 4, 14. It is divisible by 7. So that means the entire number should be divisible. Shall we quickly check? 5, 864, 355 divided by 7. You get an exact answer. There is no remainder. Okay. So this formula you can always apply for any number which is divisible by 7. Okay. So what do we call this formula? What do we call this formula? In fact, is 7. Say alternating sum of groups of 3 digits. So you always start from the leftmost digit, which is the least significant, and you count 333, make them into a group. First one, you take it minus the second group plus the third group as you continue to go to the left. You start from the rightmost and go to the left, right? So we said 355 here first, minus 864 plus whatever is the 5. And if there was another, it's a very large number after that, then it will be even this one. So let us just take another example. So who wants to give a 12-digit number to me? Other number may be a 12-digit number. Avnish, give me a 12-digit number. Come on, quickly.
Sir, so 57,
57,
82,
82,
93,
93,
57,
57,
64,
64,
15.
15. Okay. So this is the number. So we'll put it group into 3 digits. And what is the thing we have to do? So we have to start 415 plus, sorry, 415 minus 576 plus 293 minus 578. So can we do this? Who can do this quickly?
Sir, I have a question, sir. Do you always start from the back or you can go like
You have to always
570?
start from the rightmost.
You can't go like 578 minus 290.
No. That is that then it will not. So you have to always start from this. So I'm getting the answer minus 446. Now you can drop the minus sign, doesn't matter. 446. Is it divisible by 7? 7 into 6 is 42. 26. 26 is not divisible by 7. So the entire number is not divisible by 7. In fact, you can tell what will be the remainder, because 7 3 are 21 plus 5 will be the remainder. Okay. And you can even know that if this was to be, so let us see, I will quickly take whether it is 578, 293, 576, 415. This number divided by 7, it will give me 142857. Yeah, I think it is because it is giving me 57. Correct. 1, 2. It should give me a number. It is not exactly divisible. So I hope you got this one, right? So it is this is the standard formula that you can apply. There is one more formula also, but it is slightly more complicated. Actually, this is easier. Okay. In fact, you can use it for any 3-digit number if you want to find out. Actually, you can do the mathematics very easily, right? Divisible by 7 is very quick to check for a 3-digit number. So I don't think you need anything. So this is fine, I think. So you know now what is the thing for the, let me erase everything. So you know answer for 2, you know, even 3, sum of d by 3, 4, you know, last 2 digits, 5, last 3 is 0 or 5, 6, even number, even, and sum of digits by 3, 7, sum of alternating 3-digit groups, right? Sum of alternating. 8, we had discussed last time. Last 3 digits you take, and if they are divisible by 8, then you know the entire number. Why? Because 1000 is divisible by 8 exactly. 125 into 8 is 1000. So that is why any number beyond the third place doesn't really matter, because those you are multiplying that by 1000, so it will always be divisible. So only thing that matters is the last 3 digits. Okay, divisibility by 9, we had said simple sum of d by 9. Sum of the digits itself has to be divisible by 9, right? And you can keep on doing the sum of the digits. Even if they give a very large number, the sum itself come to some 3-digit number, you can again sum the digits, because if that sum is divisible by 9 only if the sum of those digits are divisible. So you can keep doing this till you get a very small number, and then you know that it is divisible. 10, you already know last digit is 0, then only it is divisible. 11, you know 11?
Yes, sir. The
What is-
alternate digits, and
Ah.
then you subtract that, and if the result is divisible by 11, or if
Correct.
it is 0,
Yeah.
then it is divisible.
Alternating sum of 1 digits should be divisible by 11, right? Everyone knows this? Avnish, Ashish, Shreyas, divisibility
Yes,
by
sir.
11. You know this?
Yes, sir.
Huh? So let us take an example for 11. Let us take an example for 11. Shreyas, give me a large number. Some 6-digit number.
So 65
65,
98
98,
32.
32. Fine. Now do the alternating sum. You do the alternating sum starting from the rightmost thing. So what do we do? 2 minus what?
No, sir. 2 plus 8 plus 5
Yeah,
minus 6 plus 9 plus 3.
yeah, correct. So what I'm doing is starting from 2. So I'm saying 2 minus 3 plus 8. Same thing, right? Minus
Okay, yeah.
9 plus what? Plus 5. Correct? 2, 8, and 5. These are the alternating thing. And minus 6. Same thing. So 2 plus what is it? 2. We can put 2 plus 8 plus 5. 8 plus 5, 13 plus 2 is 15. Minus 9 minus 6 is already 0, and then remaining is minus 3. So minus 3, again you can drop the negative sign. 3 is not divisible by 11, so this number is not divisible by 11, right? Very number. But if you were to add things, now just by 3 we are getting 3, so why don't we remove that? How do we remove? We should add 8 to
If
it.
it was minus 359832 would be divisible.
359.
359832.
Okay. So let us take the 359832. So what is the alternating sum? 2. Everything is actually everything is same except that minus
Yes.
3,
The minus 3 is
8, minus 9 plus 5 minus 3. So instead of minus 6, it is minus 3, right? Because of which, again, actually it is not. So 2 plus 8 plus 5 is how much? 15, and 9 plus 3 plus 3 is 15. So exactly 0. So 0. So this number should be divisible by 11. You want to check quickly? 359832 divided by 11. Yep, exactly. Right? Okay. So you know the divisibility by 11 also. Very good. Very good. Then what is the thing remaining? I think actually you can get a lot of numbers divisibility, because all these numbers right? So anything of which is a multiple of this, you will be able to find out, right? Very easily you will be able to find out.
yes.
So that is what. In fact, there is a formula for 13 also. So 12 is simple, right? 12 is simple. 12 is what? It should be divisible by
By 6.
4 and 3. 4 and 3. Not 2 into 6, but what is the, you divide into groups of prime numbers, right? So 2 into 2 into 3, right? So 2 into 2, you take it together, you take it, right? So what is that? So divisibility by 12 means first last 2 digits should be divisible by 4, and the sum of digits should be divisible by 3. If both things are met, then it is divisible by 12, right? Like this you can find out. So only thing that you require is for prime number. So I will just give one more thing for divisibility by 13. Okay. Divisibility by 13 is similar to divisibility by 7 in the sense that you have to find the alternating sum of 3 digits starting from the rightmost side. Okay. So let us just start with a very simple example. Okay. So what is the thing? What we should
1486.
1486. So this is nothing but is equal to 486 minus 1 is equal to 485. Right? 485 is it divisible by 13? So 13 into what? 3 is 9 and 95. 95 is not divisible by 13. So I don't think 1486 will not be divisible. So let us check. 1486 divided by 13. You get some remainder. So it is not divisible. Right? So it is not divisible. But the same principle you apply. In fact, for finding out again divisibility by 13, again for a 3-digit number, it is very easy to calculate, right? You just do 2 divisions by 13 and you can find out, right? Very easy. So take any larger number. Who has not yet given? Ashish, give a number, and you only have to do the alternating sum after that. Ashish, give a number.
How many digits?
9 digits.
Okay. 4 8
4 8
3 2 7 1
7 1
on that 5 6
5 6
3.
3. So what will you do? Groups of 3 digits. So what is this? 563 minus 271 plus
Plus 3.
483. Right? What does that number come? 563 plus 483. First to do it, or whatever it is. 3 minus 1, 2 plus 3 is 5. 6 minus 7. 6 plus 8. 14 minus 7 is 7. 7. And 5 plus 4, 9 minus 2 is 7. So I think it is 775, right?
Yes, sir.
Validate. If 775 divisible by 3 is 13 into 5, 65, 12 will remain 125. 125 is not divisible by 13. So the entire number will not be divisible by 13.
Yes, sir. Because it
Right?
will be removed.
So because 125 means 13, 13 nines are 117. So then what remains is 117, and then what remains is 8 remains. So that is what. So but if you do 8 remains. So instead of that, if you do 568, let us just do it. This number should be divisible because it will add 5 to it. 780, and 780 is exactly divisible by 13. So this number will be divisible by 13. So 483, do you want to check? 483 271 568. 483 271 568 divided by 13. Exactly you get. There is nothing after decimal sign. So it is. So you know the divisibility by 13 also. If you know all of these, right, up to 13, I'm telling you. See, there is also something 17. 15 is 3 into 5. 16 is 4 into 4, or what do you call last 4 digits you have to consider. That is what is 16. Okay, so it doesn't really matter. So what you get is 17, there is a similar thing you can check, but most likely you will not need it. I think if you know up to 13, right, almost any problem that you will typically encounter, you will be able to do it. Okay. All right. So but up to 13, you should know everybody. You should know, you should know these formulas by heart, and you should be able to very quickly do it. If you can do that, then almost anything. Let us take divisible by any decently 2-digit or even a 2-digit number. Any number you want to find out, except the prime numbers. Forget 43, 47, etc., because they are not multiples of anything. But any other number, if you take it, except the prime numbers, between say 0 and 99, or 0 and 100, 1 and 100, or whatever, right, or 10 and 100, you can very easily find out what will be the remainder by doing this, by by doing, because you know up to 13, you know, then it's all a multiple of that mostly, right? So then you can find that out. And I told if it is a multiple of this and that, then how do you know? So how do you go about it? Last week I taught, right? So that is the thing. So now there is one more puzzle like last time. Okay, you want to find out the last 2 digits of a number, which is 7 raised to 7, the whole thing raised to 7. Okay, so okay, and we can even actually, okay, let us just find out, let us just think that we have to find out the what will be the last 2 digits of this number. Okay, last 2 digits of this number.
63.
Huh?
63.
63, huh? Okay.
Yeah.
And can you explain how you went about it? Very good. So
7 sevens are 49. And then 9 into
no, wait. What
raised
are
to
you doing? It is
7.
not 7 into 7. It is 7 raised to 7.
Okay, right.
7 to the power 7 and the whole thing to the power 7. Which means 7 into 7 into 7 into 7, like this up to 7.
Yeah, 7 times.
And that group multiplied by similar thing 7 times. Right? It's a very large number. So 7 multiplied by 7, 49 times. Right? That is what it will be the number. So what do you want? So it is not easy like that. So let us go about it. So what will be the last 2 digits if you have to find out? Right? If you have to find out. Right? Okay. How do we go about it? First, let us just check what are the last 2 digits when 7 to the power 1 is equal to 7. So last 2 digits is, last 2 is just 7. Right? What about 7 raised to 2?
49.
49. And last 2 digits is
4 and 9.
Is 4 and 9. What about 7 raised to 3?
343.
343. So last 2 digits is
43.
43. Right? And 7 raised to 4. Can somebody quickly tell what is 7 raised to 4? Something
The
2001.
last digits will be 21.
7 x.
Yeah, because 343 into 7, right?
2401. It is not 21. 2401. Right? So last 2 digits is 01. But actually, the moment we get last 2 digits or last digit is 1, right? Okay, then there is a beautiful thing, because now this number, if you take it, okay, this number if you take it and raise to any power, okay, so if you take it 7 raised to 4, and that if you raise it to any power, doesn't matter what, any power, okay, raised to anything, x, whatever is the thing, the last digit will always remain 01. Last 2 digits. Because original number is something into 100 plus 01. Right? You just do it, and that if you raise it, that means you are multiplying by itself, right? No matter what you do it, you will always get the last 2 digits as 01. So what we have to see, this is the clue to finding out. So 7 raised to 7 raised to 7, we have to express it, okay, as 7 raised to 4 raised to something, raised to some x, okay, raised to some x. So So what do we do? Now 7 raised to, and it need not be what you call. So some 7 raised to, this can be some fraction also, it may come. Okay. So it may come into fraction also. So that's why it will not be. So what, you know the power of power rule, right? So 7 raised to 7 raised to 7, 7 raised to x, 7 raised to x, a, the whole thing raised to b is equal to 7 raised to any number, actually, any number raised to a into b. Okay, a into b, a multiplied b. So 7 raised to some number, raised to the some number is nothing but 7 raised to a into b. Okay, so this is the thing. So original number what we have is 7 raised to 7 raised to 7. So that is nothing but 7 raised to 49. Right? 7 raised to 7 raised to 7 is equal to 7 raised to 7 into 7. So 7 raised to 49. That is what is the number that we are talking about. And we have to find out what is the what will be the last 2 digits. But this 7 raised to 49, we can express it as 49 is nothing but 12 into 4 plus 1. Correct?
There is less than a minute left.
Okay. So what we'll do is we will I will stop recording.